Determining a general probabilistic model. By using this function and solving for x, that is, the number of projects, we could answer the question of how many projects would you need in your portfolio in order to, at least, have a better than 50% chance of making money. Given the following standard equation of logarithmic nature, y equals a times the natural logarithm of x, plus b, solving for x requires the following equation, x equals e to the power of, y minus b, divided by a. Given that x equals the number of projects in the portfolio, then y equals the probability of having negative cash flows. We can observe in the chart, the two terms calculated by Excel. Given a equals minus 0.095770, and b equals 0.907609. We now solve for different values of probability. 60. On cell I2, write the following function, equals slope, $D$12, $D$23, ln, $B$12, $B$23. This cell function calculates the a term on the function. Observe that this number matches the value calculated on the chart function. 61. On cell I3, write the following function, equals intercept, $D$12, $D$23, ln, $B$12, $B$23. This cell function calculates the b term on the function. 62. On cell I4 write the desired probability for which we want to solve the function. In this case, 50%. 63. On cell I5 write the following function, equals round, exp, I4 minus I3, divided by I2, 0. This function solves for x given a certain probability shown on the y-axis. The exp subfunction calculates the value of e to the power of x, where x equals, I4 minus I3, divided by I2. The rounded answer is 71 projects. The portfolio requires this amount of projects to make the probability of a positive outcome equal to 50%. With less than that, the probability of a negative outcome is larger. As a matter of fact, you could chart as much as 10 curves on the same graph in order to compare these probabilities. 64. Place your cursor on top of cell E9 and click on the Browse Results button. 65. In order to compare various scenarios, use the Select Simulation Number to display icon on the bar below. This will pop up the following dialog when clicking on the More option. 66. Mark on all simulations and OK. At risk will warn on the maximum number of simulations. Just click OK to accept the limit and accept to see the following chart. Several chart options have to be changed in order to make this chart more readable. 67. Slide the left wall of the statistics grid in order to fit space for 10 columns. 68. Place your cursor on the top probabilistic bar. Right-click on it and select the first option, Delimiter Options. 69. In the number of delimited curves write 10 and click OK to exit. Now, visualizing density curves one on top of the other becomes difficult because of the overlaying of curves. For this type of visualization, we recommend the cumulative ascending curve. 70. Click on the cumulative ascending icon and select it. 71. Now, make sure your vertical left delimiter is placed on 0, in order to view the probabilities of a negative outcome. On the statistics grid, the left P statistic will also show the probabilities read on the left of the probability bar. This is the same information that has been provided on the chart of the model. If you want to be certain that you will make money, in other words, that the probability of a negative outcome is 0%, you could do this by writing a 0 on cell I4. This would require a portfolio of 13,055 projects. Evidently, there will be a financial constraint on seed upfront money before these numbers are achieved. Therefore, we demonstrate the power of diversification on portfolios of mutually independent seed projects. The beauty of Monte Carlo simulation software such as At-Risk is the ability to easily build these probabilistic models on top of Excel and to make decisions based on quantitative analysis.